Okay, fifth graders, today's lesson is going to be based on this science simulator I know a lot of you have used, but if you haven't tried it out, it's even better. You can kind of see how it works. Um, this one's called Gravity in Orbits, and it shows the relationship between the Earth's orbit and the Moon's orbit in relationship to the Sun. Now, you got two choices here. You can use what's called the model or to scale. To scale really shows the size of the Earth and the Moon and the Sun realistically, if you really wanted to see what they were like. But the only problem with this is, as you can see, they both just look like little dots. But we're gonna give this a try. We're gonna show the Sun, the Earth, and the Moon. We're gonna show the path. So let's give this a shot. If you haven't used this before, this shows how many days has elapsed. You can slow it down. You can speed it up. For right now, I'm going to go to slow motion so it gives me time to select some different things. Right now it's showing its path, and as you can see, this is about 6 months worth of orbit, or about 180 days. A full year's 365 and a fourth day, so this is just about half a year, about 6 months worth of orbit. What's neat is you can select and show how much gravity force is being put upon the different objects here. As you can see, the Sun is putting gravity on the Earth and the Moon. Earth is also has its own gravity force, so as it's going around the Sun, you can see that. Velocity means speed, so you can see how fast. The longer that red line gets, the faster it's moving. So you can see how fast it goes as it goes around. So let's give this a shot. And as you might expect, the gravity and the velocity of the Earth as it goes around stays pretty constant. Otherwise, we would really feel it. We would really notice that. Okay. I am going to, if you look down here, this is about 2 years worth. You can really speed this up. Speed up time is what you'd be doing. All right, I'm going to clear this out. I'm going to go to the model because I think this shows a lot more clearly what's going on. Let's select the Sun, the Earth, and the Moon, where we want to show its path. This will show the Moon's orbit a lot more clearly. I'm going to put this on slow motion, so let's watch this for a moment. This gray line shows the Earth's orbit. This kind of purplish magenta color shows the Moon's orbit around the Sun. I'm sorry, around the Earth. Got too many objects going here. Let's put this on normal speed. So if you're out in space and can see the path of the Earth and the Moon going around the Sun, this is what it would look like. The Earth's orbit or path is nice and steady. Of course, the Moon is being affected by our gravity, so you can see its orbit. And there's about a year just went past. So if you could be out in space and watch the movement of everything, this is what it would look like over the course of a year. Kind of makes a design. The velocity of the Moon. This is really interesting. Look how the velocity changes. At certain points in its orbit, it slows down, speeds up, slows down. So the longer that red line gets, the faster it's going. Notice the Earth's velocity stays the same. Okay, we're going to pause that. Now what this down here lets us play with is things that would never really happen in real life, but what this shows you is how the mass of something affects the amount of gravity that it has. So let's play this again. and you'll notice this gravitational pull between Earth and the Sun stays constant. Now I'm going to increase the mass of our Sun. Right here is normal. This is 1.5 times, and this would be double. So let's go up to 1.5 times and see if that affects the amount of gravity that the Sun has. Okay, you can tell real quick this line has gotten bigger. Look at what happens to the path of the Earth. If you notice the moon disappeared, that means that change in gravity causes the moon to crash into Earth, which wouldn't really happen, but this is like a video game, and it disintegrated. Now, if you notice now, our orbit is no longer the same all the way around. Notice at one point during the year, we're much closer to the Sun due to this quick change in mass. So as we get closer, notice how the amount of gravity increases by a lot very quickly. So the further we are away, watch the less gravity. The closer we get, watch how the gravity increases a whole lot. Now watch what happens if all of a sudden we make our Sun with half as much mass as normal. Look what happens to Earth. It just flies off. There's nothing to keep it there. So we're going to increase the mass of our Sun by double. We're going to decrease the mass of the Earth. As you notice, it starts to come back, because this huge amount of mass has increased the amount, and there's what happens. If we had too much gravity, it sucks the Earth in. Like I said, this will never really happen. But it's kind of interesting to see how mass affects the amount of gravity something has. Let's try one more here. We're going to clear this. We're going to go to Earth with like a man-made satellite. I think we learned the other day we have all kinds of these up in space. Let's watch its path. Notice it goes around really fast. Let's watch its path. Let's take a look at the gravity force. Notice the Earth's gravity force on it isn't real huge. So let's mess around. What happens if we make the Earth smaller? Is it going to decrease or increase the amount of gravity it's putting on the satellite? Let's take a look here. Less gravity, there went the satellite. Let's increase that mass really quick here and see if we can bring the satellite back into orbit. It is taken off. Might not come back. Oh, here it comes, and there's what happens. So hopefully by this you learned maybe about the simulator if you haven't used it before, and you can also see the relationship between the amount of mass or the amount of matter something has and the amount of gravity that it puts on objects near it. Okay. Thanks for watching.